4 of our 6-week Steps of Data Analysis class. The topic for this week is Step 4, Univariate Analysis, and Step 5, Bivariate Analysis. William Bannett from Stats Whisperer bringing you the presentation. So, as usual, before we start, we want to acknowledge where we are in the 7 steps of data analysis process. And we are here, so Step 4, Univariate Analysis, and Step 5, Bivariate Analysis. So if we break these terms down, uni means one, unicycle, one wheel, uni, one, and var meaning variable. So univar, one variable. So it's analysis of one variable, right? So we're presenting an analysis of one variable. So we want to make this make sense to us. Univariate analysis is also called descriptive analysis because we are describing variables. So you could look at it this way. On a dating site, people describe themselves, and they call that description a profile, right? So here's eHarmony, and there's Monica from New York, and gender female, age 32. And so people describe themselves. It's a profile of themselves. So it's the same thing with a variable in univariate analysis. What we're doing is we're making a profile of that variable by itself, right? So the variable might say, hello, my name is the variable happiness, right? The average score or the mean score of happiness might be 3.5 on a 1 to 5 point Likert scale, right? So we're getting familiar with each variable. So to best illustrate the univariate analysis as well as the bivariate analysis, we will apply steps 4 and 5 to sample study 1. So recall, sample study 1 involves 4 variables, right? On the right, we have the dependent variable. We're explaining happiness. On the left, we have the 2 covariate variables, the predictors, which are education level and income level. And the third predictor is our independent variable, do you live with a dog or a cat, right? So our purpose is to see how these 3 predictors impact happiness. So the big question is we have our 4 variables for sample study 1. How do we get to know them via univariate analysis? Well, the first step might be to look at the univariate test key. So that's going to tell us which univariate test to use according to the structure of the variable. So the variable, we have categorical and we have continuous on the left side. Then on the right side, we see that the univariate test for each of them is going to be frequencies. So we're going to run frequencies in SPSS. However, when we run those frequencies, for the categorical variables, we're going to note the number and percentage of study participants within each category. For the continuous variables, we're going to note the mean, the standard deviation, and the highest and lowest scores, which are we call the minimum maximum scores for each continuous variable. So to do this in SPSS, here's our path, right? So to run frequencies, just go to Analyze Descriptive Statistics and Frequencies. You transfer the variable you want to analyze from the left to the right-hand column, And under statistics, we'll click mean standard deviation, continue, and then OK or paste. And this is actually pretty simple, so we could go ahead and do that ourselves. So we have our SPSS right here. So as we said, we go to Analyze, Descriptive Statistics, and then Frequencies. And then happiness is in there already, but let's pretend it wasn't. So we go down here, and there's happiness. So we move it over to the right-hand column. And then we want to take, stretched out there under statistics, we check mean and standard deviation, and then continue. And then we can either paste it and save the syntax, or click OK. And there we have, right, there's our printout. So there's the mean score, the standard deviation, the minimum score, right? So this is the frequency table, the lowest score, the minimum. So someone got a 1.20, and then someone got the highest is a 4.4 on the happiness scale. So it's relatively simple, but not totally simple. Okay. So after we get those values from SPSS, we might put them in a table. So we probably have one table for continuous variables and a second for categorical. So of the 4 variables in this study, we have 2 continuous, which are happiness and income. You see them listed on the left. And then the next column you could see, there's the mean. So the mean for happiness, 2.73, the min-max, and the scale range. It's good to mention the scale range because, you know, the minimum and maximum would have a different meaning if the range was, say, 1 to 10, right, and the highest score was 4.4. It would mean there's not a lot of really happy people. But if it's 1 to 5 and the highest is 4.4, we know some people are getting close to that highest maximum happiness level, right? Then we have our categorical variables, right, run the same way in our frequencies, except this time you get the breakdown by the number and percentage. So education level, we see for high school there's 32, which is 32%. Their highest education level is high school. The next college, right, so it's 29% at college level. And at graduate school, an N of 39, which means 39 study participants in that category, and which is 39% of the sample, because the sample is 100 people. So roughly about, in education level, there's roughly a third of study participants at each level. And then do you live with a dog or a cat? We see for dog, there's 47 people, which is 47%. And for cat, there's 53 people, which is 53%. So roughly, you know, half the sample lives with the dog and half the sample lives with the cat. So what we've done here, right, just like you might on the dating site look at profiles of people, we've looked at the profiles of all 4 variables, right? We've gotten familiar with education level, income level, living with a dog or a cat, and happiness. So now we're familiar with each variable before we do any sort of inferential analysis, seeing which variables are associated with one another. All right, now, bivariate analysis. Again, breaking it down, bi meaning 2, bilingual, speaking 2 languages, and then var, variable, so 2 variables. So we're presenting an analysis between 2 variables. It sounds so innocent at this point, but you'll see it's a little more intricate, right? So our goal here, right, so bivariate analysis could be used for several goals, but our goal here is to use bivariate analysis to determine significant one-on-one relationships. So significant means statistically significant with the p-value less than 0.05. So significant relationships between the covariate variables and the independent variable and the covariate the independent with the dependent variable, right? So if there's a significant relationship between the dependent variable and one of the predictors, we're going to enter that predictor in multivariate analysis, which is next week. But this is used to determine which variables will go forward as predictors into multivariate analysis. And this will become a lot clearer. But the big take-home message right now is that we're just testing the one-on-one relationships between the dependent variable and the predictors to see which predictors the dependent variable is associated with at a statistically significant level. And that's much easier to understand when we do it rather than say it, so now we're going to do it. So our goal is to answer these three questions. And so on the left, we have the predictors. So for example, is education, does education have a significant relationship, shown by that arrow, a significant relationship to happiness? And that's test 1. So we see test 1, significant relationship, question mark. Then covariate variable 2, income level, right? You see the arrow going to happiness. So we want to know, is income level significantly associated with happiness? In other words, does your level of income have a significant effect upon your happiness? That's the second test. Then the third test is the independent variable, right? Do you live with a dog or a cat? So there's a significant relationship between living with a dog or a cat upon your happiness. So these are 3 tests, 3 bivariate tests that we're going to run, and it's going to answer our 3 questions, as in, is each significantly associated with happiness? Now, here's another key. To select the correct test, the correct bivariate test, you have to consider the structure of the variables. Now, the structure just means, continuous or categorical, and we're going to break that down a little, right? So we're going to consider 3 variable structures. The first one is continuous. Is the variable continuous? Right? So 2, categorical with 2 categories, right? Such as, do you live with a dog or a cat? That's 2-category answer. And 3, categorical with 3 or more categories, i.e. more than 2 categories. Right? So education has 3 categories. It's categorical with 3 categories, high school, college, and other. So if you keep these 3 variable structures in mind, you can determine which statistical test you need for the bivariate analysis. Now, another question you might ask is, how many statistical tests do we need, right? Do we need 1, 2, 3, 4, 10, 12, right? Well, essentially, if you go in the parametric route, there are 4 statistical tests, in this cross-sectional study that we can use to test our bivariate relationships, which are the t-test, and we'll be using independent samples t-test, the chi-square, 3, the ANOVA, and we'll be using the one-way ANOVA, and 4, correlation, and we're using the Pearson's R correlation, which is probably the most widely used form. So here's the bivariate test key. This will tell you all you need to know in selecting the correct bivariate test to compare the variables. So first, it's generic. Okay, so first it tells you, see variable A and B. So there's bivariate, there's always 2 variables, and we'll call those A and B. Right? And the structure of each will tell us which test we need. So for example, if you have the categorical variable, 2 categories, and a continuous variable, the t-test, the independent samples t-test. if it's categorical with more than 2 categories, and it can pair it up with a continuous variable and ANOVA. The third line says if it's 2 continuous variables, a correlation, and the fourth line says if it's 2 categorical variables, the chi-square. And so we can better understand this if we plug in our variables into that table. Right, so bear in mind we have one dependent variable, happiness, which is continuous on a scale of 1 to 5, and we have to compare each variable to that. So the right column will just make happiness, and then the left column will put our 3 predictors, which are 2 covariate variables and 1 independent variable. Then we'll be able to see the relationship between them. So here we go. And if you're doing this with your own study, this is useful sometimes just to write the names in there and which test to use. So we see here, right, the top line, categorical with 2 categories, which in our study is, do you live with a dog or a cat? But it could be any categorical variable with 2 categories, such as yes, no, recover, didn't recover. Okay, that matched up with a continuous variable, you would use the t-test, specifically the independent samples t-test we'll be using. If it's categorical with more than 2 categories, like education is, right, high school, college, and graduate school, paired up with a continuous variable, it's the ANOVA, the one-way ANOVA we'll use. And if it's 2 continuous variables, like income level and happiness, you would use the correlation. Right? So there's a little guide here. And we have to switch around the happiness because we want to show the chi-square. What's the chi-square used for? We don't want to leave it out, even though it's not part of sample study 1. So if we have 2 categorical variables, such as lives with a dog or a cat, and education, you would want to use a chi-square. And we'll get into in-depth, what each test is looking at and what it means in one moment. Okay, now we're going to implement each of the 4 bivariate tests, the t-test, chi-square, ANOVA, and correlation for sample study 1, one at a time. So first, let's consider the ANOVA, specifically the one-way ANOVA. What does it do? What's its purpose? And so what it does is it examines if there are significant differences regarding mean scores, in our case, mean scores of happiness. Right? So the mean score suggests the continuous variable, right? And the continuous variable is happiness. So it exists on mean happiness scores for a variable with more than 2 categories, such as education. So what it's looking at is, do the 3 groups of education, the high school, college, and graduate school, is there a significant difference between the mean scores of happiness between each group? So to do this in SPSS, and this is in the text too, right, you go to Analyze, Compare Means, One-Way ANOVA. The factor variable is the categorical variable, and where it says dependent list, we put in happiness. Then you have to remember under post hoc to click Bonferroni, Continue, and under Options, click Descriptive and Continue, and then click OK or Paste. And let's do that in SPSS. Right, so we go back to our database right here. So as I said, we go to Analyze, Compare Means, One-Way ANOVA. So education level, as I said, education level goes in the factor, and the continuous variable, happiness, goes in the dependent list. Right? So that all looks fine and good. Then under post hoc, we click Bonferroni. You have to click it, it's not by default. And then under options, you click descriptives. And then again, you click either OK or paste. Now we could click paste, right? And it gives us this, which is the, so instead of clicking OK, if we click paste, we get the syntax, and we could just save it anywhere we like, right? Save as, just like any other file. And that way, instead of clicking OK and it's gone, we click paste and we can save it for as long as we need. You highlight it and then click run. There you go, and that's the same as OK. So here is our output. So we're going to go over this in the slides. So you can see here we have our these are the descriptives. Remember, we clicked descriptives, right? So these are the descriptives. So the N, meaning how many people were in that group. So the N, 32 people in high school, had a mean score of 2.1687. So that's their happiness score. The college, 29 people, a mean score of 2.6966. And the graduate school, the 39 people, had a mean score of 3.2256. So is there a significant difference between the means? Well, we can't know by looking at that. So we look at the ANOVA table, and it's 0.000. So that's telling us that the test is statistically significant. But then the problem becomes, which mean is significantly different from the other means? So is college significantly different from graduate school? Graduate school significantly different than high school? We don't know. So that's probably the post hoc test, the Bonferroni. So that tells us, the little asterisk here says it's significant at the 0.05 level. So high school, it's saying college is significantly, is significantly different right here, right? So you can see by the asterisk, they're all significantly different from one another. Now let's go back to the slides because the output's there too. So our point is this is the output, the descriptives and the ANOVA table. So there's a lot of numbers, but you need to know which ones to look at first, right? So there we go. Sorry, so you can see it turns yellow there. So the first thing to look at, as we did, is the mean, right? The mean scores. So we see that there's almost like a trend where it's lower for high school, higher for college, and highest for graduate school. Then we see in the ANOVA table the significance, saying that's a significant difference. Then when we go to the post hoc, it's saying that, you know, that high school is, see the minus, significantly lower than college and graduate school. And graduate school is significantly higher, see, positive numbers, than high school and college. And the college is significantly higher than high school, but lower than graduate school. Right? So there we go, the one-way ANOVA. So then we can enter that right here in the first test. And so our little diagram, we can actually put the result. So test 1 equals significant, as in there's a significant relationship between education level and happiness. So we've answered test 1. Now our next assignment is to answer the second one. See the middle line, income level and happiness. So is that significantly related? Well, let's find out. Recall, income level and happiness are both continuous. So we see continuous and continuous on the bottom is a Pearson's R correlation. A correlation, we're using the Pearson's R. So what's the correlation going to tell us? So the correlation, right, so correlate, that's what it means is as one goes up, the other either goes up, which is a positive correlation, or as one goes up, the other goes down, which is a negative correlation. Or third, there could be no correlation at all. So what we want to know is when income goes up, does happiness either go up significantly or go down significantly, or is there no association at all? So that's what this test is going to tell us. So to do a correlation in SPSS, this is probably the simplest one. You go to Analyze, Correlate, and Bivariate. Then you enter the continuous variables, which for us are happiness and income level, into the right-hand column titled Variables, and click OK or Paste. So let's do that real fast. So we go over here, Analyze, and then Correlate, Bivariate. So here's happiness, right? So we took happiness from over here and put it there. We took income level from over here and put it there. And then there you go. So you click OK, and you see here Pearson is checked. So that's the default, and two-tailed is the default. So the Pearson R is what we want. By the way, the non-parametric version is the Spearman here. So if you had a small sample or for some other reason needed a non-parametric, you just, instead of clicking Pearson, click Spearman. And then, instead of OK, we can say Paste. And go to the syntax. And then we just highlight it and click Run. And there's our output, right? So let's go look at the output. So there's our output that we just saw. So the question becomes, what numbers do we look at? Well, you could see that the numbers are on the same in the top and bottom. So the 1 divides the top and bottom, but they kind of reflect each other. So you only need to look at one box. So you can see that the P level is 0.000. So it's below 0.05, so it's a significant relationship, right? And the 0.884, that's the correlation coefficient. That's the actual effect size for the test. But what we're concerned with is the significance level, right? So we've answered our question. So income level is significantly correlated with happiness. And again, we saw that the 0.88 does not have a minus sign in front of it. So that means it's a positive relationship, right? So that means as income increases, happiness increases. If there was a minus there, if it was negative 0.88, that would mean as income increases, happiness decreases. But there's no minus, so it's positive. So we've answered our first two questions. Education level, significantly related to happiness, yes. Income level, is it significantly related to happiness? Yes. So now we're going to the third question, right? We're going to look at that third test. So we're looking at, do you live with a dog or cat? Yes, no. And happiness, which is continuous. So the dichotomous variable being related to a continuous variable. And if you recall, with our bivariate test key, right up at the top, the first line, if you have a categorical variable with two categories, such as living with a dog or a cat, and a second variable which is continuous, such as happiness, you would use a t-test. Right? So the t-test, in our case the independent samples t-test, is going to tell us, and this is a lot like the ANOVA, except it's more than two categories, the ANOVA. Is there a significant difference in mean scores, right, among the two categories, living with a dog or a cat, right, regarding happiness? So in other words, do the mean scores for happiness differ among people that live with a dog or a cat? Test in SPSS. To do the test in SPSS, you just simply go to Analyze, Compare Means, Independent Samples, t-test. Then under Grouping Variable, we'll put our categorical variable, and then you have to put the codes for each group, as in, did you code as 1 and 2 or 0 and 1, or we'll go over that. And then 3, the test variable. Under test variable, you put the continuous variable, and then it's OK or paste. So let's do that in SPSS. So, as promised, analyze, compare means, and independent samples t-test. All right, so far so good. So then we want to take, do you live with a dog or a cat, right here, our independent dichotomous variable, and we put it here. Now when it says define groups, you need to click that. Now we could have coded living with a dog or a cat as 1 and 2 or 1 and 0, but that's significant here, right? You want to make sure that you have the right thing. You'll just get an error message if it's not correct. But probably the smart thing to do is actually verify it before you enter it as such. So you can see right here, 1 equals dog and 2 equals cat, and that's what that means. So we say define groups, we put 1 and 2, and continue. And then under the test variable, recall, we want to put the composite score for happiness. There we go. And then you can paste it, or say okay, or paste it. And then under syntax, you have it right here. And reading the syntax, once you get past the shorthand of it, is pretty intuitive. So you say t-test, the groups are living with a dog or a cat, and they're coded as 1 and 2. And then it says the variable that it's being compared by is happiness. Right? So it's not too arcane. So you highlight it and click OK. And there we go. Right? So there's the first, the group statistics, that's the descriptives, and then the actual test. So we have that here too. So let's actually look at that here, because we have our little highlighting. So here we go. So the top table is the descriptives. And what do you say? The means, right? And then the bottom test is the test results, right? So there's a lot of numbers. So which ones do we focus upon, at least initially? There you go. Right? So what we want to look at is who has the higher or lower mean score, and is there a significant difference? Is there a statistically significant difference between those mean scores? So we see for the dog, people that live with a dog, there's 47 of them, and their mean score is 3.02. So their mean score of happiness on the 1 to 5 scale is 3.0213. For the people that live with a cat, there's 53 of them, and their mean score on the happiness scale is 2.4792. So there's a difference, but is it statistically significant? So where it's highlighted here, significant two-tail, that tells us if it's significant. So 0.000 is less than 0.05, so that means the difference between the two means is statistically significant. Now one thing you got to keep in mind too is where it says Levine's test here, that's telling us if there's equal variance among the two groups. So it gives you an F, and then it gives you a sig. Now the important thing to know is if the sig for the Levine's test is significant, 0.05 or lower, you would actually use the lower set of numbers. So where it says T is 3.8, the degrees of freedom is 97.8, you would use that lower line to report. However, since it's not significant, 0.87 is a lot bigger than 0.05, you would use the top line, the T 3.8 degrees of freedom, 98, right? So that's a little tip there. But the take-home message is there's a significant difference in the mean scores. So there we go. We have answered all 3 questions, right? So education level is significantly related to happiness. Income level is significantly related to happiness. And living with a dog or a cat also has a significant impact upon one's happiness in this study. Now, the other thing is we don't want to leave out the chi-square, right? So they didn't fit in our scheme because variable B is continuous, so we don't have a chance to do the chi-square. So we slipped in another categorical variable, so we put in education. So we're relating education to do you live with a dog or a cat, right? So does your education level, say, have a significant impact with whether you get a dog or a cat to live with you? And again, this could be any two categorical variables. So it could be intervention A and B and education level. So looking at would an intervention work better for differing levels of education. So the chi-square is going to tell us if the proportions within the categories differ significantly for the two categorical variables. Right? So as we said, the research question might be stated as, does living with a dog or a cat differ significantly by education level? So there's a couple of ways to do the chi-square in SPSS, and one of them is to go to Analyze Descriptive Statistics and Crosstabs, and then put one variable in the column, preferably the dependent variable, and then one variable in the row, right? And perhaps the independent variable. Then under Statistics, click chi-square and continue. Then under Cells, click Row and continue. Then click OK or Paste. So we could do that in SPSS2. There we go. So Analyze, Descriptive Statistics, then Crosstabs. Then here we have our education level, right? And we might put that per se in the column. And then living with a dog or a cat, we might put that in the row. Right? So then we go under Statistics, click chi-square, and this is the effect size, the phi Kramer's V, but we won't do that now. Cells, we click under percentages, we click row, continue, and then we give the paste it or say OK. We'll say paste. Then we'll go to the syntax and highlight it and click run. And there you go, right? So let's look at the output here as we have our highlighted version. So actually we have the dog and cat in the column here. Sometimes it's interesting to look at it both ways, especially if you're not sure of the research question. Okay, so we could see, do you live with a dog or a cat? Right? So what do we look at? Right? There's a bunch of numbers. Well, it's not that hard, so there you go. So in the dog column, right, we could see, so you go across. So high school, right, you could see that there are, of the people whose highest education level is high school, 14 live with a cat and 24 live with a dog, which means 63% of them, 63.2, live with the dog. Now you can see that's a lot higher. So in the college category, only 31.2% live with the dog, and in the graduate school category, only 20% live with the dog. And so there's our raw numbers to look at. And then if you look at the second table, the Pearson's chi-square, you can see that the significance, which is the statistical significance, is below 0.05. So there's a significant relationship between the two variables. That's what that tells us. Okay. Now, again, recall, we used bivariate analysis to identify the significant one-on-one relationships between the predictors and the dependent variable. Right? So we didn't note the effect size, which is always important. Right? We didn't note the effect size because we want to focus on significance, because our goal here is to determine what's going into the multivariate model, and we're not considering the effect size. We're basing that upon the statistical significance, right? But we are going to look at the effect size between the predictors and the dependent variable, the covariate variables, the independent variable, and the dependent variable in the multivariate analysis. But the bivariate effect size are all covered very well in the text if you need to analyze those as well. And our results told us that all the covariate variables and the independent variable had a significant one-on-one relationship with the dependent variable happiness. But note here, you can't tell at this level which of those predictors has the strongest impact on happiness. You just know each one is associated with happiness. You don't know which has the strongest impact on happiness. That speaks more to the effect size. And that's why we want to look at that at the multivariate level, because that's where it really counts. That's where it's the most credible, because we're looking at the effect of all the predictors at the same time on the dependent variable. Right? So which is it? Of all the predictors, which one variable has the greatest impact on happiness beyond all the others? Again, you can't see it in this step, but you will see it next week in step 6, multivariate analysis. Right? So, as you might have guessed, yes. So along our continuum, we will be at step 6 next week, multivariate analysis. So it was sort of a cliffhanger, huh? So anyway, thank you for watching this week, and I will see you in our next webinar video.